Now we're going to start talking about some properties of proportions. And the first property that we're going to talk about is the cross products property of proportions. A proportion is an equation stating that two ratios are equal. There are two ways to write a proportion. One is using colons. So you'll notice that the equal sign is actually two colons next to each other. So this one says A to B is the same thing as C to D. Whilst we're talking here, let's talk about the means and the extremes. The extremes are the first and last numbers in the proportion, so in this case A and D, and it's easier to see in this format, so that's why I want to talk about them now. So A and D are on the ends, the extreme portions of the proportion. The means are the middle two numbers in the proportion. So B and C are in the middle. We know that the mean is an average. It's in the middle of two numbers. That should help us remember that the means are B and C. Now, remember that we can write a proportion, and often write a proportion using the vinculum, or write them as two equivalent fractions. In which case, notice that your extremes are on the top left and the bottom right. And your means are on the bottom left and the top right. That's very important to know. So the cross products property of proportions, and remember how I talk about the addition property of equality and adding things to both sides of the equal sign and getting the full name in there? The reason for that is because the cross products property of proportions only applies if you have a proportion. If you do not have a proportion, you cannot use this. So this states that in a proportion, the product of the means and the product of the extremes are equal. So if A over B is equal to C over D, then A times D is equal to B times C. Before we use this, let's go ahead and prove it. Now, before you start whining, this is actually a very easy proof because all that we're going to use is the properties of equality. For example, here we have A divided by B. How are we going to undo that division? We're going to multiply both sides of this equation by B. On the left-hand side, B reduces out, and on the right-hand side, we now have CB over D. But again, we want to get rid of that D, so how are we going to undo that division? We'll once again multiply both sides of the equation by D, and so now you see we have AD equals BC. So as you can see, the multiplication property of equality is all that we need to prove this property works. So now let's use it really quick. Here are two quick examples. What is the solution to each proportion? That means we need to find the value of the variable. So in number one here, all that we need to do is use the cross product property of proportions. So 6 times 11 is 66, and 8 times x is 8x. And then we divide both sides of the equation by 8 and reduce. 2 goes into both 66 and 8, so x is going to equal 33/4, which also happens to be 8 1/4. On the second problem, we're going to do the exact same thing. We'll use the cross products property of proportions and multiply y plus 6 and 8 and multiply 12 and y. Now remember, when multiplying y plus 6 and 8, we need to use the distributive property of equality. So we get 8y plus 48, and that is going to equal 12y. We'll now subtract 8y from both sides of the equation, so 48 is going to equal 4y. And then if we divide both sides of the equation by 4, we find out that y is equal to 12. Again, not too terribly difficult.